In this video, I'm going to teach you about significant digits. Know that I might be switching words and saying significant figures instead of significant digits, but they both mean the same thing. So why do we use significant digits? Well, chemistry, we do a lot of labs. And in the labs, we collect a lot of data. And it's important that our measurements are as precise as possible. And when we talk about precision, we can really only be as precise as our equipment will let us, right? So if we are using a beaker and it's going up by 100, right, 100 increments, I can't say that I have a volume of 12.2, okay? So I'm trying to be more precise than my equipment will let me. So significant digits is a representation of the number of digits in a measurement that includes all the numbers you are absolutely sure of, plus one estimated number. It indicates precision of a measurement. So if we look at this graduated cylinder and the water that's inside it, and I am asking you to read the volume of this water, we're looking at the meniscus, and we see that it's going up by 0.2. So we can say that it's somewhere between 6.6 and 6.8. Now, if I want to be precise, I will say that it's probably right around 6.62. So what were the numbers that I was absolutely sure of? It was 6.6. What was my estimated number? It was the 2. So 6.62 at the end was my estimated number. And these are my significant digits when I read the volume of this liquid. Here's another example. Let's say we have this bug and we have this ruler. Can you tell me what the measurement could be? Well, it's maybe 0.6. What part of that was I sure of? I was sure of the 0 point. The part that I guessed was the 6. What about this one? Now that we have this ruler, I would say it's probably around 0.62. What part was I absolutely sure of? 0.6. What part did I guess? The 2, the last part. What about this one? This one, I would have to get really close to it. And I would say that it's probably right around 0.635. So what part was I absolutely sure of? I was sure of the 0.63. The part that I guessed was the 5. As a ruler gets more precise, my measurement can also be precise, right? And so the more markings there are, the better our precision will be. So these were the actual numbers of the length of the bug. Ruler A only gave me one significant digit. Ruler B gave me 2 significant digits. And ruler C, I was able to do 3 significant digits. So significant digits, or you might hear me say sig figs or sig digs in class, just for short, are a way to indicate how confident you are of your data. Again, more significant digits there are, the greater confidence we have with our measurement, and the more precise our number. Now, there are 4 rules that we need to consider when it comes to significant digits. So here's the first rule. Non-zero numbers are always significant, meaning any number 1 through 9 are significant. So we count them as a significant digit. So for example, we have 72.356. All those numbers are above 0, and so all 5 of those are significant. 5 significant digits, SDs for short. How about the next number? We have 6 significant digits, and I'm just counting them left to right. 6 significant digits for that one. Rule number 2. Zeros between non-zero numbers are always significant. So the zeros are inside the non-zero numbers. See how they're in the middle? So 800.28. Count that left to right. We have 1, 2, 3, 4, 5 significant digits. How about 60.5? we have 3 significant digits. Let's take a look at the third rule. All final zeros to the right of the decimal place are significant. So we have zeros, they come at the end of the number, and these numbers have decimals. So when we have a number like this, all the numbers will be significant. So again, counting it left to right, we have 5 significant digits on our left, and again, we have 5 significant digits for our right number. Let's take a look at the last rule. Zeros that act as placeholders are not significant. Here are your examples. Notice where the zeros are. On the left side, the zeros come before the non-zero numbers, and those have a decimal. How about the right side? It looks similar to rule number 3, right? But what's missing? A decimal is missing. So these zeros are just acting as placeholders. So let's count these. So 0.00163, these zeros don't count, and so we have 1, 2, 3 significant digits. Again, the beginning zeros don't count, and we have 1, 2 significant digits. How about this number? We have 1, 2, 3. That last zero doesn't count, it's just a placeholder, and so that's 3 significant digits. And the last number, again, that's 3 significant digits. So, how can I make this easier for you? Well, let's take a look at this map trick. We're going to do a little bit of geography. Let's talk about oceans. What's on the left side of the US, and what's on the right side of the US? On the left, on the west coast, we have the Pacific, and on the east coast, we have the Atlantic Ocean. Well, the P in Pacific is going to stand for decimal that is present, and the A in Atlantic is going to stand for decimal that is absent. Let's take a look at a number. We're going to place the number in the middle of our map. Let's say 830. And this is how the trick works. Does this number have a decimal? It does not have a decimal. The decimal is absent. So we're going to start counting from the absent side. We will start counting from the east side, meaning we'll start counting from right to left. As you count from right to left, what is the first number that you hit? It's a 0. If you begin with a 0, we're simply going to ignore and move on to the next number. What's the next number that we hit? It's a 3. It's a non-zero number. So if it's a non-zero number, we're going to go ahead and count that number. So we have 1, and after that, every number counts. 2. We have 2 significant digits. Okay, let's take a look at another one. How about 83,000? Well, decimal absent or present? Decimal is absent, so we're going to start counting from the right side, right to left. So what do we hit first? The arrow hits a 0 first. We're going to skip through all those zeros until we hit our first non-zero number. After that, every number counts. So in this number, we have 2 significant digits. How about this number? Decimal present or decimal absent? Decimal is present. So this time, we're going to start counting from the left side, the present side, the Pacific side. So we're counting this number left to right. What's the first number that we hit? It's an 8. It's not a 0. So we're going to count that number. Once you hit your first non-zero number, every number after that counts, even if it's a 0. So this number, we have 5 significant digits. Let's try another one. And I'm going to pull out a pen for this one. Let's say I have the number 0.000837. 0. Decimal absent or decimal present. My decimal is present, and so I'm going to start counting from the left side, and I'm going to count it left to right. Well, what's the first number that we hit? It's a 0. So we're actually going to skip through that 0 and every 0 until we get to our first non-zero number, which is the 8. After that, every number counts, even if it's a 0. So for this particular number, how many significant digits do we have? We have 3 significant digits. Now you try. Go ahead and pause the video and try to determine how many significant digits we have in each of these numbers. You can use the math or you can use the rules. Go ahead and play the video when you're ready. Here are the answers to the practice problems. Did you get it? If you did, virtual high five. Now, what do we do with all of that? Are we just going to keep counting numbers? No. What do we do with data that we collect? We do some math. We have to analyze it. So when it comes to math, we're really going to talk about just 4 main functions: adding, subtracting, multiplying, and dividing. Because really that's all it's about. So when you add and subtract, an answer can have only as many decimal places as the fewest number of decimal places in the starting numbers. Now notice what I highlighted. I highlighted decimal places. So forget for a quick second that we just talked a lot about significant digits. Because right now we're just going to talk about decimal places. So let's take a look at an example. Go ahead and write this example on your paper. We're going to add up these 3 numbers. And using my calculator, or just your head, we get an answer of 9.401. Now, with significant digits, we're not going to put all these numbers down on our paper, okay? So what does this mean? Here we have a very precise number, and here, not so precise. Your answer can't be this precise if one of your measurements or data is not that precise. And that's the whole point of significant digits, okay? So here we want to go ahead and count the decimal places. So our first number, we have 3 decimal places. Second number is 1 decimal place. And third number is 2 decimal places. So where should our answer stop? Well, look at the rule. Our answer can have only as many decimal places as the fewest number of decimal places in the starting numbers. So where does our answer stop? At the 10th place. So our answer is, well, you still have to look at the rest of the numbers, right? So when you're at 4, you're looking at the 0, you're seeing if it's going to round up or not, and it's not. And so what happens to the rest of the numbers? We basically cut it off, and our answer is 9.4. Let's take a look at the second example. We have these 2 numbers. Put it on our calculator, and this is what we get for our answer. We're going to go ahead and look at the decimal places. 4 decimal places here, 2 decimal places here. So where will our answer stop? At the 2nd decimal place. You're going to look at the 1 to see if that rounds up to 4 or not. And it doesn't, right? 5 and up round up. So our answer is 3.4. Now, what do you do when you multiply and divide? An answer can have only as many significant digits as the fewest number of significant digits in the starting numbers. So now, everything that we talked about in the beginning, bring it all back. This is where we count significant digits. So let's count. 2.000. Decimal is present. We start counting from the present side. And how many significant digits do we have? We have 4. How about 1.5? Well, that one's easy. It doesn't have any zeros, right? So everything's significant, so it's 2. So where will our answer stop? It can only have as many significant digits as the fewest number of significant digits. So we're going to stop our answer right here at 3.0. That's 2 significant digits. So we multiply and divide in order to count these 2 significant digits. You're really counting it from left to right. Okay, so left to right, those are your 2 significant digits. Let's take a look at our second example. Here we have 5 significant digits, 2 significant digits. So where does our answer stop? It stops at the 5 for 2 significant digits. Okay? But we have to look at the 9, the number that's right next to the 5, and see if that will affect it or not. And it does, so we round up our answer, and it's 4.6. Let's take a look at this example. We need to calculate the density. Remember the density formula? Density equals mass over volume. Let's set it up. This is division, right? So I'm just going to go ahead and calculate the answer, and there's my answer. So if we divide, what are we looking at? Well, we need to count significant digits. So on top we have 4, on the bottom we have 2. So where does our answer stop? If you said 2 significant digits, you are correct. So where are the 2? Left to right, 1, 2. So our final answer is 5.0 grams per milliliter. How about this example? Find the mean. Well, you're going to add it up, and you're going to divide by 4, and we get an answer of 1.8. And so, according to the rule, what do we have to look at? Decimal places, okay? And so you're thinking, wait, but why decimal place? There's a 4 there, so you're dividing, so it should really be 1 significant digit, right? Wrong. That's not part of the data, right? Significant digits is it's only used with our measurements. If it's not part of our measurement, then it doesn't matter. So 4, because that's not part of the data, we don't consider in the final answer. And so our final answer is actually 1.8. Fewest number of decimal places. Okay, the 10th place. So go ahead and try these. In the first column, I want you to go ahead and just put in your calculated answer, the original answer using your calculator. And then the rounded answer is the answer with significant digits. So I'll go through the first example with you. The first problem, the original answer just using my calculator is 142.92. But we're adding, right? So where does my answer stop? We're looking at the decimal place, and it stops at the 10th place. So it stops right here at 0.9, and there is my final answer. Go ahead and try these problems on your own. Apply the rules, look at your notes and apply the rules, and see what your rounded answer is going to be. Go ahead and play the video when you're done. So for number 2, our original answer is that. Our rounded answer with significant digits, well, this one, did you get it? It's 214. You have 100th place, right? But this one is just a whole number. So then your answer would need to stop at the whole number. So that's how we got 214. Number 3, we have 360. It only has 1 significant digit from the 50, from the number 50. So how do you make this 1 significant digit? Because that's the only one. Well, I mean, you're still doing the same thing, right? Look at the 6. What does a 6 do? The 6 makes the 3 round up. So there's my 4. But what do you do with the rest? Gotta put in placeholders. So it becomes 400. Does that answer make it 1 significant digit? Yes, it does. If you put down 4 from the original answer of 360, would that have made sense? No. How is 4 anywhere near 360? It's not, right? So it'd be 400. And last one, we need 3 significant digits here, so we have an answer of 2.99. Go ahead and pause the video and try these practice problems. When you're ready, play the video so that you can see the answers. In class, I will ask you if you have any questions. So if you do have questions, just hold on to them and we'll cover them in class.